All right, welcome back to All Out Practice. Now we're on the pink one, and this is number 3. This one, each one has a little bit different, has some different elements in it, so I'm hoping this gives you some good help. Number 1, what is the maximum number of roots for the equation above? So the most I can have is 4 solutions. Some of them could be multiples, but 4 is the number. Next, list all the possible rational roots for the function above. If I couldn't cheat and look on my calculator, it'd be a good idea to be able to try some certain ones. The ones I would try would be the factors of that number, which would be plus or minus 1, plus or minus 3, and plus or minus 9. Technically, you always take whatever your roots are and see what they would be if you divided them by all the factors of the lead coefficient. However, when it's a 1, if you divide any of those numbers by positive 1, you get themselves. And if you divided all of them by negative 1, you just get the opposite of themselves, which is already there. So my possible roots are plus or minus 1, plus or minus possible rational or real ones that you could see pretty easily on the graph are plus or minus 1, plus or minus 3, and plus or minus 9. So those are your ones that you'd want to try. Next, I said draw a sketch of your function. So you'll see that I already put it in. I already hit zoom standard, and then after I hit zoom standard, I went to the window and I changed, and this is on the pink sheet, the x min to -5, the x max to 5, and the y max to 20, just because I thought I could see it a little bit better. Ooh, and that's interesting. That's like a W. All right, so if I graph that and put it on my paper, I'm going to be honest with you, I'm pretty certain that it crosses at -1, and I am also pretty certain that it crosses at 3, and then it just looks like it does some funky W. Okay, so it's going up on both of the ends. Okay, so looking at your sketch, which of your possible rational roots is a definite root to try? Well, I think -1 is it. And I also think 3 is it. None of the other ones are it at all. And it only touches at 2, which is weird because I have that up there. Okay, let's look here. I'm going to write my coefficients down before it slides up. And my coefficients are 1, -4, -2, 12, and 9. And then I'm just going to try 3 first. And I'm going to try 3. Bring the 1 down. 1 times 3 is 3. Add -1. -3 and add. -15 and add. -9 and add. I'm not shocked that it worked out. Now what's a little tricky is that what's left is 1x to the 3rd minus 1x squared minus 5x minus 3. I cannot use the quadratic because this is a cubic. This one goes to the 3rd power. But lucky for me, I have 2 options here. So I'm going to try -1 into what is left. So what was left was a 1, a -1, a -5, and -3. If it is a root, it will go into what was left here. Bring down the 1. -1 times 1 is -1, and I'm going to add. -1 times -2 is 2, and then I'm going to add. -1 times -3 is 3. Ha ha, and that worked great. Okay, and then I look at what's left. I have x squared minus 2x minus 3. And I said before, I'll be honest, I like the quadratic formula because I don't have to worry about what does it factor into and then flipping signs and all kinds of crazy stuff. So I'll do the opposite of b, plus or minus square root b squared minus 4ac all over 2a. That gives me 2 plus or minus square root. I know most of you would go to your calculator to put in the discriminant. That's what's underneath the square root. Although you can do this one in your head, I'm sure.